Hello friends, in this presentation we will aim to analyze the construction and working principle of a special transformer called AutoTransformer, including the types and different application of this AutoTransformer. Topics we are attempting to go through are as follows. Firstly, the introduction to this special type of transformer, the AutoTransformer, following the principle of operation and the theory of AutoTransformer, we will be looking into the important voltage and current equations that are linked with this AutoTransformer, and finally we will be looking into the advantages and disadvantages and how the AutoTransformer is used in different industries. If you recall about conventional transformer, they are passive electrical devices that transfers electrical energy from one electrical circuit to another, or it can be multiple circuits. So what are AutoTransformers? Work on the same working principle as a conventional transformer, but with only difference of that AutoTransformer has only a single winding which is common to both primary and secondary side. Hence, portion of the same winding act as both primary and secondary sides of the transformer. Just like a normal transformer, this can also act as step up and step down transformer. Or they are certainly lighter, and this makes them certainly lighter and cheaper and smaller in comparing with the other conventional transformers. So this transformer is basically used to change the voltage levels by a small amount in a power system. Further, we will look into the principle of operation of this transformer. Okay, so let's consider the basic AutoTransformer circuit on the right. As you can see, there is a one common winding between primary side and the secondary side. The AB winding is the primary winding, which has a tapping at node C, while CB acts as the secondary winding. So the supply voltage is across AB, while the load is connected across CB. So hence, when the AC voltage is applied across the primary winding, and because of the Faraday's law, an EMF is induced in the primary side. This EMF is then, because due to the mutual induction, this EMF is also induced on secondary side. While EMF induced in the winding is proportional to the number of turns. Therefore, the secondary voltage can be varied by just changing the secondary number of turns. Another thing to note here is that most of the energy is transferred by the means of the electrical conduction, and a small part through induction. Now let us see the basic theory of AutoTransformer and explore the voltage and current relationships in an AutoTransformer. So if you see the diagram of the step up AutoTransformer on the right, here VL and IL are a voltage and current on low voltage side respectively, while on the high side VH and IH are the corresponding components. And as we can see, the winding AB is series winding because it is connected in series with the common winding. Hence, BC is the common winding because its voltage appears on both sides of the transformer. Another thing is that the number of turns in the series and common winding are represented by NSE and NC respectively. So you can see the voltage relationship of VH over VL, the ratio is NC plus NSE over NC, while in the current relationship it's just the reverse. This also follows the basic transformer equations. With these equations for voltage and current, we can derive a very important conclusion of the AutoTransformer, that is the apparent power rating advantage. So the ratio of the apparent power in the primary and secondary of the AutoTransformer to the apparent power actually traveling through this winding is given by this equation. Here SIO is the apparent power entering the primary and leaving the secondary side of the transformer, while SW is the apparent power actually traveling through the transformer's winding. So note that the smaller the series winding, the greater the advantage. This equation actually describes the apparent power rating advantage of an autotransformer over a conventional transformer. For example, if you reconnect a conventional transformer into an autotransformer, so the new apparent power rating supported by this autotransformer through this equation will be much higher than the conventional transformer. Its detailed derivation of apparent power can be found in the Chapman book of electric machinery. Now let us see the types of autotransformers. So there are three types of autotransformers. The first one is step-down autotransformers. You can see it in the diagram, where number of turns on the primary side is greater than the number of turns on the secondary side. This converts high alternating voltage to the low alternating voltage. Secondly, step-up autotransformer, where number of turns of primary are lesser than the number of turns on secondary. This type of transformer converts low alternating voltage to high alternating voltage. Third one is a very special one, autotransformer, variable autotransformer, also called variac. It has the capability to produce variable AC voltage from a fixed AC supply. It actually contains a variable tap in the form of a carbon brush that slides up and down. In an actual variable autotransformer, there is a knob on top of it where you can adjust it by yourself. So what makes an autotransformer more desirable and preferable over a conventional transformer? So let's see its advantages. Due to its single winding, it has a considerable saving in size and weight. Because it has a smaller size, it reduces installation time, cost and labor effort at the same instant. Further, autotransformer are more efficient than a two-winding conventional transformer. So because of due to low losses in ohmic and core, efficiency of a conventional autotransformer can reach up to 98.8%, while an energy efficient autotransformer can have 99.2% efficiency. Voltage regulation of autotransformer is much better than a two-winding transformer. It is due to its short circuit impedance that goes down with the corresponding, ensuring that the lower voltage drop. This is why autotransformer is better known for good regulation. Further, because it has a single winding, there is less copper used comparing with a two-winding transformer. It also needs lesser excitation current to compare with a conventional type of autotransformer. It has a type of a variable autotransformer. We can vary the output as per our requirement, while in a conventional transformer, step up and step down voltage are fixed. Let us see some disadvantages of this autotransformer. First of all, autotransformer cannot be used for high voltages. So in case of any discontinuity or an open circuit in the primary side winding, it will result in complete primary voltage applied on the secondary side. This can be very dangerous for the whole system and for the humans nearby. Nextly, autotransformer does not provide primary to secondary winding isolation. So it is not safe to transfer large voltages to secondary side. This can be very hazardous. Thirdly, in case of any short circuit, output voltage across winding becomes significantly higher than the operating voltage across it. This will damage the autotransformer. While current is much larger than the transformer rating, this also results in primary to be short-circuited further, resulting in reduced effect of resistance and reactance. Lastly, as we look into the application, autotransformers are used widely across many industries. For example, in railway application, they are used as booster transformers, in power distribution lines, with special automatic tap changing equipment are used in certain as voltage regulators. Tapped autotransformers are used in audio devices. These devices are to adapt speakers to match the impedances, as well as to adjust the device to a constant voltage supply. They are also widely applied in shipbuilding and shipyard industries to basically and the big initial stages to start up the system. transmission gears, and etc. etc. Because of its adjustable voltage output, it can be used to control the speed of the motor. Further, like with the many small other application like device testing and compensating for the loss of voltage, these applications and analysis proves how AutoTransformer is so desirable and important among many industries around. Thank you for this. Feel free to post questions below.